Use similar polygons. So today we want to identify congruent angles and corresponding sides of similar polygons, and then use the properties of similar polygons to solve problems. So first, what are similar polygons? Two polygons can be similar if all of your corresponding angles are congruent, so every angle congruent, and all corresponding side lengths are in proportion, so they have the same proportion between the two. So if we've been given these two polygons, A, B, C, D, and E, F, G, H, and we're told that they're similar, then I know that my corresponding angles, AE, B, F, C, G, and D, H, I know that all of those must be congruent. And then I also know that if I was to take my side lengths and write a proportion of my side lengths, if I was to simplify that proportion, these would all be equal. So side AB to EF is going to be the same proportion as BC to FG. And notice that I have the same polygon on top all the way through, and the same polygon on bottom all the way through. So then I need to write my similarity statement. This little line right here, the squiggly line, that means similar. And notice that all the corresponding vertices are written in the same order. So A is congruent to E, B to F, and so forth. Just like in our congruent statement, your angles and sides have to line up. All right, so let's look at example 1. So we want to use our similarity statements, and I've been told that triangle ABC is similar to DEF. So first I want to list all of my congruent angles. And if I know that these are similar, then I know that B and E are congruent, A and D are congruent, and C and F are congruent. The next thing we need to do is make sure that our side lengths, our corresponding side lengths, are in proportion, or that the ratios are equal. So I'm going to set up my proportion, and if I look at AB to DE, that's 10 over 15, which simplifies, make sure you're simplifying, to 2 over 3. BC to EF simplifies to 2 over 3, and CA to FD also simplify to 2 over 3. So all of my side lengths simplify to the same proportion. They are the same proportion. So then I want to write my corresponding side lengths in a statement of proportionality. And a statement of proportionality simply means that you are showing that the proportion of the sides are all equal. All right, let's talk about scale factor. So scale factor, if you've got two polygons that are similar, then the ratio of the lengths of the corresponding sides is called the scale factor. So in example 1, our scale factor from DEF to ABC is 2/3. So to get from this triangle to ABC, we multiplied our side lengths by 2/3. So let's find the scale factor of these two polygons. So first of all, I need to make sure that they're similar. So I want to check all of my angle measures and show that all of the corresponding angles are congruent. So I can see that Z and F are congruent. I can see that Y and G are congruent based on the markings. H and X are congruent, and then W and J are both right angles, so they have to be congruent. Next, you need to show that corresponding side lengths are proportional. So we're going to take each one of these measurements, set it up in a ratio, simplify the fraction, and confirm that they're the same. So when I take zy to fg, it becomes a ratio of 5/4. Yx to gh, also 5/4. Xw to hj simplifies to 5/4. And last, wz to jf also simplifies to 5/4. So I've got congruent angles and I've got side lengths that are in proportion. So my scale factor of FGHJ to ZYXW is 5/4. To get from this little polygon to this bigger polygon, I would multiply each side length by 5/4. All right, let's look at example 3. So in my diagram, I've been told that these two triangles are similar. So I want to find the value of x. So since I know my similarity statement, I know which side lengths should be in proportion. So I can set up a proportion. I know that BD is in proportion with RT, and CD is the corresponding side to ST. So that's my proportion, and now I just need to plug in my numbers. So 5/10 is equal to 13 over whatever x is. And then when we solve for x, we get that x is 26. So as long as you can set up the proportion, you should be able to solve for the unknown. Now, what's special about perimeters of similar polygons is that your perimeters are going to maintain the same scale factor. So if you know that your two polygons are similar, then that means that their perimeters are going to be similar with the same ratio. So I know that KLMN and PQRS are two similar polygons. So that means all of my corresponding sides are going to have the same ratio. But that also means, if you recall what perimeter means, it's the distance around and you're adding everything up. That means that the distance around KLMN is going to be the same distance around PQRS. So whatever you find is your scale factor between the sides, you can use that for your perimeter as well. So in example 4, I want to find the perimeter of a new court, basketball court, and an old basketball court. But the first thing we need to do is find the scale factor of the new court to the old court. So I'm going to start by drawing a picture. And the large cement court is being poured. The new court is going to be 20 feet wide and 25 feet long. So obviously my pictures were not drawn to scale. So 20 feet wide, 25 feet long. All right, and the old court was similar, but it was only 16 feet wide. And I want to find the scale factor of the new court to the old court. So I want to go from the new court to the old court. So I think from and to. So I'm going to do new to old. And that's 20 on the bottom, because that corresponds with my new one, and 16, because remember, I don't know what this side length is. So 16 here. So my scale factor is 4/5. If I'm going from my new court to my old court, my scale factor is 4/5. Now, I could easily figure out what this value is, and then we could add it all up because it's a rectangle. But instead, I want us to use what we just learned about perimeters. So we are going to use this scale factor here to figure out the perimeter of our old court. So my perimeter of my new court is going to be all of my side lengths added together, so it's going to be 90 feet. So in order to find the perimeter of my old court, I'm going to take my same order. Notice old was on top up here, old is on top over here. So old to new, that's x over 90, x standing for my perimeter, and I can come over here maybe, there we go, and say that x over 90 equals 4 over 5. So now I'm going to solve that ratio, and I get that the perimeter of my old court must have been 72. So whatever this value is up here, we should probably use a different letter since I used x in my example. Whatever this perimeter was up here, if you found y, you should be able to add up all your sides and it would be 72. All right, corresponding lengths in similar polygons. So last unit we learned a lot about different segments in triangles, altitudes, for example. So if two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to that scale factor as well. That means altitudes. So in the diagram, I know that this bigger triangle is equal or similar, to this littler triangle, and I want to find the length of the altitude GL. So if I know the similarity statement, then I know that this side JK is similar to this side FH in the bigger triangle. And I also know that GM is the altitude of the smaller triangle, but it's corresponding with GL, which is the altitude of the bigger triangle. So I can set up this proportion to find GL, which is my altitude. So 10 to 16 must be the same proportion as my two altitudes. One of them I know, it's 14, and the other one I don't know, it's x. Now, some of you may be asking, how do I know it's an altitude? Well, I know it's an altitude because it comes from the vertex and it goes to the opposite side and makes a right angle, and it's perpendicular. So the distance we are looking for is this. This is the x that we're looking for in this problem. And once you've got your proportions set up, you just cross multiply, solve for x.